Okay, so a circle as defined in geometry is all of the points equidistant from a given point. Okay, so if you have a point here, let's say there's point A, and you start plotting all of the points that are, I don't know, 1 centimeter away from this. There's one there, one there, one there, one there, and hey, there's one there and one there. And if you kept doing that, and I'm not doing this very neatly, but if you kept doing that for a long time, then a circle would start to emerge. And if you did all of the points, it would form a circle. Those are all the points on the circle that are 1 centimeter or whatever it is away from point A. Okay, so there's a similar definition for a parabola. The parabola is going to be the set of all points that are equidistant, the same distance, that means, from a given point and a given line. Okay, so I'll describe what I mean. So here I've got point F, so that can be the point that we're equidistant to, and here's line D. So if I want a point that's the same distance from this point as it is to line D, well, there's one point right about here. I'm just eyeballing this, but I think we can all agree that point is the same distance from F as it is to D. Okay, but there's many other points. I could put a point, let's say up here somewhere. So this point would, if you think about this distance, and then when I'm going the distance from a point to a line, you want to go the perpendicular distance, so straight down there. So these are supposed to be congruent. Okay, so there's another point, and I'm eyeballing this again. Okay, I could put one, I don't know, somewhere up here, and again, just eyeballing this, but that perpendicular distance, let's say that that's about equal to that. Okay. And so there are many of these, and if you were to start drawing all of them, eventually you would see that you've got a parabola. Okay, so a parabola, if I drew one neatly and measured, any point on a parabola is going to be the same distance from a particular point and a particular line. Okay. All right, so the point that is called the focus. So that's why you use the letter F. Okay. So this is the focus. Okay. And it's always inside the parabola. That's good to know. Okay. That first point we drew that was directly below the focus is the vertex, right? That's the vertex of the parabola. Okay. And then the line, I call that line D here. This is the directrix. That is what that particular line is called. Okay. And also something that's worth noting, the axis of symmetry of this parabola, that's the line that goes right down the center, cuts it in half right down the center. It's also going to go through the focus and the vertex. The focus is right in the middle of the parabola, okay? So this is my axis of symmetry. Okay. All right. So there's something called my p-value. If I scroll out a little bit here, I'll just scroll down. Okay. My p-value is going to be the distance from the vertex to the focus. Okay, so this distance then that's the p-value, okay? Or it's going to be the same actually as the distance to the from the vertex to the directrix, because if you think about it, the vertex is halfway between the focus and directrix, so that means that this could also be P. Okay, so it could also be from the vertex to the directrix. Okay, so just some vocabulary. You got to know, but the focus is the point on the inside, the line's the directrix, and then this distance is P, and this distance is also P. Okay, all right, so we've got some parent graphs here. I'm going to just put in some dashes, because those didn't print out very well. Okay, so the first one is the parent graph of a parabola, and I know it's going to open upwards from the vertex, right? Well, from the origin. It's going to open upwards from the vertex, which is the origin. It's the point 0, 0. Okay. Here, so let's graph this. I'm going to go up 1 to the right 1 because, you know, if I plug in 1 for x, 1 squared is 1. If I plug in negative 1 squared is positive 1 as well. If I plug in 2 squared is 4. And negative 2 squared is also 4, so here's our parent graph. Hopefully that's pretty familiar. When we've got y equals negative x squared, it's going to look similar, except it's just going to open downwards. So that's going to be a reflection over the x-axis of the first parent graph I had. Okay, so those two should be familiar to you, but we haven't looked at x equals y squared or x equals negative y squared. Okay, so this is a big moment because finally got sideways parabolas. They've always opened up and down. X equals y squared will open to the right, so it's going to have the same dimension. So here's my vertex, and instead of going, you know, up 1 to the right 1, well, I'm still going up 1 to the right 1, but then I'm going down 1 to the right 1, okay? And I'm going to go up 2 to the right 4, and down 2 to the right 4. Okay, and this is a new parent graph. So an x equals y squared parent graph. Okay, and you can probably guess what's going to happen here. This one's going to open to the left. Shouldn't put those so close together. Maybe I'll just draw this much of it so it doesn't look like it forms a big ellipse there. Okay. All right, and the reason this happens, you could take the square root of both sides of this equation if you wanted to solve it for y. So some people might just write this, but if you plug in some xy pairs, that's really only going to be the top half of the parabola. But really, when you take the square root of both sides, there's a positive root and a negative one. So you could rewrite this like so, and then we'd have you get the whole parabola. So you could try graphing that on a calculator, but you'd have to graph it as two separate functions, one with positive square root of x, one with negative square root of x. Okay. All right, so there's the first page. Let's move on to the next page. Okay. So on the next page, I'm going to talk about something I call focus-vertex form. Okay. So I've got these four parabolas, which are the parent graphs that we were looking at on the previous page. So first thing I'm going to do is just divide my paper up into kind of a chart into these four different sections. Okay. All right. So focus-vertex form is a lot like vertex form. It's got one new little feature though. Okay. So here's what this first one's going to look like. Okay, I've got 1 over 4p times the quantity x minus h squared plus k. So, got the h and the k would give me my vertex, right? So that's the same as before. The new feature is this fraction out in front. Yeah, vertex is the point hk, right? So I can tell the vertex, okay? So remember, your focus is going to be, and I actually don't know where the focus is for this problem, but let's just say that the focus is just right here, okay? Because I don't know the that's the parent graph, but that's my focus. This is just supposed to be a generic parabola. Let's say that this is the directrix. So remember, the p-value is going to be in here, right? Or you could say it's down here, okay? So I call this the y equals x squared version, just because this opens upwards just like y equals x squared does, right? So that means this is going to be my y equals negative x squared, just meaning it opens down. It's that version of it, okay? This one opens to the right, and that's when I'm going to get x equals y squared version and x equals negative y squared version, okay? So let's the focus for each of these is going to be inside the parabola. So since this one's opening down, I want to put it somewhere in there, okay? This one's going to be somewhere in there, and you know, from the vertex I'm going along the axis of symmetry, and that one will be in there, okay? And then the directrix is going to always be outside of the parabola. So if I'm going from the focus to the vertex, just keep going the same amount, and there's my directrix for this one. So that means for this one, it's going to be actually a vertical line, because it's never going to intersect the parabola. So just go from the focus to the vertex, keep going the same amount the other direction. This one will end up out here. And so with these ones that open left and right, we end up with a directrix that is vertical instead of one that is horizontal, okay? All right, so the equation here is pretty similar. It's going to be just like this one, except it's going to have a minus in front of a negative symbol in front of the fraction. So I've got y equals negative 1 over 4p x minus h squared plus k. Okay, and the vertex will still be the point hk. Okay, and the p-value would still be in there, right? I'm not going to keep marking what the p-value is. All right, so it gets a little weird with the ones that open sideways. You might think, oh, you can just switch the x and the y, and that's sort of true, but you have to do something else, okay? So yeah, I am going to write x equals, and this one's going to be positive here, so I have 1 over 4p, okay? And this is going to be a y. That all is true. You're just kind of switching the x and the y so far, okay? But what you want to do, think of the h is going to give you your x coordinate, right? So I wouldn't want to put minus h, because I wouldn't want the h to be with the y coordinate, okay? So I want the y is going to come from the k. The y and the k are a group. The x and the h are a group, okay? So instead of saying y minus h, I'm going to say y minus k inside the parentheses, okay? And that means that this is going to be h. So yes, the x and the y switch, but also the k and the h have swapped from where they were in the versions that open up and down, okay? And then this version is going to look just like this, except you've got a negative fraction. Okay, so if the number inside is attached to a y coordinate, it's going to give you the y coordinate of the vertex. If it's attached to an x, it's going to give you the x coordinate. Okay, and so that means my vertex is still going to be the point hk for all of these, since I took the time to rewrite those formulas where it was switching the h's and the k's. Okay, all right, so let's try this out. Okay, so first thing I'm going to do on this next problem is decide which of these 4 versions I'm dealing with. So I've got y equals 1/16 x squared. So it's a y equals version. It's one of these, okay? And then I'm looking, hey, there's no negative in front of there, so I've got my y equals x squared version, okay? So I'm thinking right off the bat, you don't necessarily have to write this down, but I'm thinking I've got one of these. It's going to open upwards, okay? So let's start looking at this thing. Okay, so the vertex, hopefully you're getting pretty good at finding the vertex when we're in vertex form. My x-coordinate would be 1, and my y-coordinate is 2, right? That's my h and my k. So I can say 1 is subtracted, and then 2 is just the k value. Sorry, I'm off screen there. So my vertex is going to be 1, 2. That is super important for graphing, right? That's my most important thing, I'd say. So the point 1, 2, and I know it opens upwards. That's pretty important too. But I've got my vertex, okay? I know this opens upwards, and for now, we could actually take some time and figure out the width of the parabola. But just to start with, I'm not really worried about the width for now. I'm just going to sketch in any old parabola that opens upwards from there, because I want to draw attention to the focus and directrix right now and make sure I can teach you how to get those in the right place. Okay? So we could do those other points with an XY table or a stretch and compression, but let's just leave that for right now. So I've got my vertex there. This is opening upwards, okay? And what I want to do now is figure out the value of P. I know my focus is going to be somewhere inside of this parabola, so we got to figure out where, all right? And that's where this is going to come in, okay? So if you look at the original equation I have up here, 1 over 4p is what goes in front of the parentheses. So I can say 1 over 4p is going to equal whatever's there, which in this case is 1/16. But if it was a 7, I'd say 1 over 4p equals 7, okay? And then what I want to do is solve this equation for p. So I'm going to cross multiply when I have two fractions that are equal, and then 4p equals 16, right? Divide by 4, and p equals 4, okay? Some teachers teach you sometimes that p-value might come out negative, and that could tell you that it opens either downwards or to the left. But as long as you can look at the equation and know which way the parabola opens, you don't really need to worry about that. I already know it's opening up, and I know I'm going to go up to get to my focus, because the focus has to be inside the parabola, right? So now I know how far I'm going to go up from here. I'm going to go 4 units. So let's see, 1, 2, 3, 4. 1, 2, 3, 4 puts me right there, right? Hey, I've got my vertex. So this was the p-value, which is 4. I just went 4 units inside the parabola to get that focus. And you don't need to draw that stuff. I was just trying to explain that, okay? And I can also use the p-value to get to the directrix. So I went 4 inside the parabola to get to the direct focus. I'm going to go 4 outside, 1, 2, 3, 4. And this is just a point right now, but it's marking where the directrix is going to go. It's going to be, you know, since my axis of symmetry is vertical, this is going to be a horizontal line that goes through that point. And then, you know, if someone asked me for the equation of the directrix or the coordinates of the focus, that would be no problem, right? So this would be the point 1, 1, 2, 3, 4, 5, 6. This would be the point 1, 6. And this would, it's going to be a y equals line. It's going to be y equals -2. Okay? So there, I've graphed that with a focus and a directrix. Okay? All right, let's try some more on the next page. So I've got this one. First thing I'm thinking, what type do I have here? I can see it's an x equals 1, so I know it's going left or right. And then I've got a positive fraction, so this is an x equals y squared version, and it's going to open to the right. So that's what I'm thinking right off the bat. Okay? So let's start working on this. Okay. So let's find the vertex first, okay? Now the vertex on this one, there's going to be a lot of people who make mistakes, but I hope you're not going to be one of them. So a lot of people will say that the vertex is going to be -2, -1. And I totally understand why people do that, because we're kind of trained to look for, oh, the opposite of that number, just how it is. But this is incorrect, okay? This is where you have to really be careful, because this is going to give you the y-coordinate of the vertex. So think y plus 2 equals 0. That means y is -2, not x, right? So be careful there. And that means that this one is just going to be the x-coordinate on this one, since the y is already spoken for, right? This is my x. So my vertex is going to be -1, -2, not the reverse, right? Okay, so -1, -2 puts me right there. I know it's opening to the right, since I'm not worrying about the width right now, even though we have covered that and we could deal with that. Not worrying about the width of that, just getting that going the right direction from the right vertex. And I want to make sure that we get the focus and directrix in the right place. So to do that, I'm going to need the p-value. Okay, I know I'm going to go inside here to get the focus. I'm going to go outside here to get the directrix. I just need to know how far to go. And that's where this is going to come in. So 1 over 4p is going to equal 1/12. Okay, I'm going to cross multiply. 4p is going to equal 12. And that means p is 3 once I divide by 4. All right, so I'm going to go 3 units to the inside. 1, 2, 3. Here is my focus. I'm going to go 3 units. 1, 2, 3 to the outside. I'll just put a little mark. And then I'm going to put a vertical line that goes through this. And here is my directrix. Okay, so let's see. This was 2, -2. And this would be the line x equals -4. Okay. All right. So this next one is, I think, a little trickier because this time we're going to write an equation. Okay. So my recommendation when we have to write an equation in Focus-vertex form is to plot what you got. Put what you have on a graph. You don't have to. If you can visualize this all in your head, that's great, but I think it makes it a lot easier. Okay, I've got a vertex at 1, 2, 1, 2. There's my vertex, okay? And I've got a focus at 1, 0. 1, 0, there's my focus. So just that information, now I can actually figure out which direction it opens. Remember, the focus has to be inside the parabola. So I know my parabola is going to go through the vertex. So, hey, that means that this is going to open downwards, right? I know it's going to be this version, okay? And then we can go back to our Focus-vertex form. I know I've got this type, right? I've got a y equals negative x squared version, so I can use, this is from the previous page, right? So I can use that formula and start trying to plug some things in. Okay, so there's only a couple of things that I need here. I need to figure out what P is, I need to figure out what H is, and what K is. And H and K were kind of given, right? This is the point 1, 2 is the vertex, and that means this is my H and this is my K. So I'm already ready with those, right? So I just need to figure out the p-value. So the p-value is this distance. So now that I've got those graphed, I can see, oh, that's just 2 units, right? My p-value then is 2 units. And some people might say, and some books actually say that this is -2 because it's going down. But I always think of it as a distance, so it's positive. And if you use the right formula that I provided, I already got the negative in there. So I know this is going to open down if this whole fraction is negative. Okay. So I'm going to plug in 2 for P there. Okay. And then I'm going to plug in 1 for H and 2 for K. And then I just simplify the fraction, and there's my equation. And that's it. Okay, see you next time.